at point P, we have to draw a straight line which is a tangent at point P, which passes or which touches point.
Welcome to today's exciting lesson. Before we begin, I would like to encourage you to invite your friends, classmates, brothers, and sisters to join Mugombi Online School, where learning becomes simple, enjoyable, and effective. Together, let's build a strong community of successful learners. At Mugombi Online School, we are committed to helping students excel through clear explanations, quality lessons, and continuous support. For registration or any inquiries, contact our help desk on WhatsApp.
We are going to cover a gradient of a curve. Rule number 1, the gradient at any point on a curve is equal to the gradient of the tangent to the curve at the point. That is rule number 1. And then rule number 2, the gradient of a curve changes from point to point. Let us take a look at this graph. Y is equal to 2 plus x minus x squared, which ranges from minus 2 to positive 3. We have got point Q, point P, and point Q. And then for us to calculate the gradient at point P, we are required to use the tangent to find the gradient of the curve at point P and Q. So the gradient at point P, we have to draw a straight line which is a tangent at point P, which passes or which touches point P exactly. So our coordinates, we are sure that point P has coordinates 0 and 2. So we need an additional point along this line which touches or which has got exact points like these ones at 1 and 3, as we can see here, or at minus 2 and 0. Any of these points are enough for us to calculate the gradient at point P. So we are going to use these coordinates 0, 2 at this point, which we are sure of, and these ones, which is minus 2 and 0. So these 2 points, they are enough. If we say 2 minus 0 and then 0 minus 2, that is the gradient of the curve is equal to y2 minus y1 over x2 minus x1, which is equal to 2 minus 0 over 0 minus 2. This will simplify and give us positive 2 over positive 2, because 0 minus 2 is 2. So 2 over 2 gives us 1, right? So this is the gradient at point P. As we said earlier, according to our rules, we said that the gradient of a curve changes from point to point. So we want to see if this is true. We are going to calculate the gradient at point P. So the gradient at point P, at point Q, we have got the coordinates 2, 0, and we have to find any other suitable points along this line, as we can see. So this one is a suitable point for us. So how are we going to use it to calculate the points? This is positive 3 for x and negative 3 for y, like this. So the points will be this one. So the coordinates at this point, they are 3 and negative 3, right? So we are going to say y2 minus y1 over x2 minus x1, which is minus 3 minus 0 over 3 minus 2, which is equals to negative 3 over 1, which is equals to negative. Right? Remember the concept which I told you previously, which says that if a line slants like this from left to right, tichitange tikukwidza makata, inenge ine positive gradient. Tikatange tikudzika materu, inenge ine negative gradient, sezvakafanana nepanapa. So already zvinotibatsira kuti kana ndaita mistake, let's say ndakakulira panapa pane iri riri kuna P, ndikabudisa negative gradient, zvinoona ndatoita mistake, I have to recheck handitika then iri ukaona ndikabudisa positive gradient pane line rakasilana zvazvizvi, it means ndaita mistake, nokuita recheck my figures, ndobva ndabudisa the correct gradient. So zvinobatsira maningi izvozvo. So let us now proceed to the next concept. We can also make use of this point, which is equal to 1, 3, because 1, 3 lies exactly at points which you can see, which are 1 and positive 3, exactly at this point. So it is advisable that you have to choose points which are exact. Don't choose the points which are difficult to estimate their value, because it will be difficult for you to calculate the gradient. For example, choosing any point like this point when it is in between this point, iri pakati pekaline kadikidika, zvinondinetsa kuti nditange kukalkulate ndi-estimate rather than kuti ndichoose point inonyatsa kuita. You get the sense, right? So let us now proceed. So in this case, we are going to cover example 2, where we are required to draw the graph of y is equal to 1 over 4 x squared for values of x from minus 2 to 3, and then find the gradient of the curve at the point where x has the value 3 and then -2. So the first thing, mashure mutambopiwa graph ranga rakadhura kudaro. Now takufanira kutanga tadhura graph to calculate the gradient. So we need a table value first from -2 to +3, and then we have to calculate, starting from this point, we have to substitute the actual points which we have. We have to substitute the actual points. Let us take a look here and see the point where x is equal to -2. If we substitute -2 at this point, we will get +4, which is -2 squared, which is +4, and we'll get 1 here. So likewise, we are going to substitute the available value of x in this value until we get all the required values in the table of value like this. And let us proceed to calculate. We can cross-check our calculations. These are the calculations, and so we will produce the actual or the correct table of value, which is this one. So we have to use the table of value to draw the graph. So using the x values, which ranges from -2 to +3. So -2 for x, it means that our value for y, we need to position our y-axis in such a way that there will be enough boxes to include the negative values of x like this one, and then enough boxes to include +3 values of y. The same for when positioning the x-axis. As we can see, the x-axis is 0. This is the minimum value. The maximum it is 2.25. So it means we do not need negative values. So we must increase positive values much than negative values. So we have to position it like this and just label it like this, from -2, from 0 to +3, and then the negatives as well as including the positives for y like this. Then we'll continue to draw a graph. Then to plot my points. -2 na 1. This is -2, 1. Then you locate the point, and then -1 na 0.25. 0.25 is quarter. So we have to check. In this case, we are saying each small box is representing 0.2. Because in the 5 boxes to skip on 1. So 0.2, 0.4, 0.6, 0.8, then 10 bana 5. So each one is 0.25. So box 1 quarter. So you have to be very careful, right? And then you have to proceed. So 0, 0 is this one, and then 1 in the 0.25, then 2 na 1, then 3 and 2.25, unaenda pana 3, what 2.25, this is our point. Then you draw this curve and draw smoothly. Usashandise ruler nekuti unozotsvaga zvizobude gradient yakanaka naika. Then you have to produce and continue smoothly, neatly, zvakanakisisa sezvizvi. Then from this point, you are required to calculate the gradient when x is equal to 3. Saka when x is equal to 3, unoenda pana x kana r3. X kana r3 ndepana. Then wofamba usvika unobata curve yako. Then you draw a tangent which touches the curve. Tangent iri harifaniri kucross a curve. This is very, very, very careful. Tangent harifaniri kucross a curve. Harifaniri kutombocross a curve tangent. Then our point yatiri sure nayo ndeiyi inonzi 3, 2. So we need to find another estimate point along this line, which we are going to use to calculate the gradient, isn't it? So 3, 2 toshandisa point ipa. Ngatishandisa imwe point inoita. Saka ndokwanisa kushandisa point kana kuti, let's say this point iri panapa iyi inoiti ndokwanisa kucalculate apa. Iyo ndi 1.5 pakati nepakati apa na 0. It's very easy to calculate that one. So I'm going to use this one to calculate the gradient. So gradient is equals to y2 minus y1 over x2 minus x1. And then we have to use it to calculate the points. 2.25 ndikatangana kuno. 2.25 minus 0 over 3 minus 1.5. 2.25 minus 0 into 2.25. 3 minus 1.5 into 1.5. So I got 2.25 over 1.5 to give us 1.5. So this is our gradient, isn't it? So then the gradient, when x is equal to, the gradient when x is equal to 2, the repeat gradient, to point when x is -2, and minus 2, then we draw a tangent. And this another important calculate this gradient. It must have a negative gradient. So our coordinates, this point are -2 and 1. We need to find another most possible point, which is this one, which is -1 and 0. And then we are going to make use of this one. Gradient is equals to y2 minus y1 over x2 minus x1, which is equal to 1 minus 0, 1 minus 0 over -2 minus -1. Be very careful. Sakangano minus -1, which was 1 over -2 minus -1, and -2 plus 1, which is equals to -1. So minus 1 over -1 is -1 gradient. So this is our actual gradient, as simple as this one. So that's how we calculate the gradient of a straight line. Please go ahead and calculate and answer the questions that follow on this exercise, which I have uploaded on the website. And if you are not yet registered, please visit our website mugombionlineschool.com and register for your full course. You can also WhatsApp us on this number or SMS or call these numbers.